So now, last video, we took this 555 timer here, which I got out of this kit. So it may not be the best 555 timer, but any case, we are to the positive supply, of course. That's going to the reset pin. We are not resetting this. It's wired to be A-stable. We could go up to 12 volts, but I'm just going to stick with 5 volts in this video. And if I lower this enough, we will get a low input to the reset timer, and the output will stay low. But there you can see it already kind of affected it. And there we go. Now we got it low enough, and the output is low. It's going to hold it low no matter what. Now if I slowly turn this up though, it won't have to go very far. Now we actually have a high output, and we may get some weird stuff in between. Whatever. So in any case, I don't remember the reset pin acting like this, and it should never be holding the red LED high. Either we should have a high input so it's not doing anything, and so high enough voltage, or a low input so that it holds the output low. So here is a component kit I got a long time ago. I got it from Radio Shack. They weren't terribly cheap, but they may have been worth it. I think it's kind of iffy if you can find them now. They were discontinued. But in any case, they have any 555 timers in there. If it says 555, it could say any, maybe micro A or something else. But 555 is the important thing. And these are probably my highest quality ones. I think I used these in my earliest videos. Maybe they were the ones I measured in the past. So I slipped them out of the bag right here, and on this foam, and we have 5. So obviously I plucked 5 and stuck them somewhere else. They're going to have the same pin layout as the other one that I was just using, and the pins are a little too wide right here. Kind of common when you get a new integrated circuit for the board. So I'm going to line them up. There we go. Get them on one side, kind of squeeze them so they move in a little bit. Try that with the other side. Kind of working my way back and forth. So I know you can't really see what I'm doing. I'm kind of pushing 4 in and shifting them. And I'm at kind of an awkward angle here. I should really do this when there's no components. So I'm going to go down here where there are no components. And there we go. Force it in the board. Now, that's in there pretty good. There we go. The integrated circuits slide in and out easier once they get used to the breadboard. And I think we're, there we go. I can see much better with my right hand there. Working my way around the camera. Alright, and there we go. Hopefully that wasn't too painful to watch. And we'll put this here. So, yeah, I think this will be a higher quality 555 going to 2 to 6. Now I'm going to turn the power on. You should really turn the power off whenever you are making changes to the breadboard. And definitely that was a good idea this time. We should not have damaged it. But yeah, this one, okay, now I do have a middle ground region that I was hoping I would not have right there. So yeah, looks like even this one. This is a completely different 555 timer. It's probably a whole lot older than the other one we looked at. And yeah, it looks like it's going to be about approximately the same input when it comes to the reset there. So I wanted it where it'll never be high like that. So if I'm going to switch this, I will have to use a, some way to get a digital input going there, where it's either, oops, I did not want to go to 15 volts. That's actually what I was trying to avoid doing, but I have current limited, so we shouldn't have caused any damage. And we got a kind of a lot of current, oh, we're even above 30 this time, because we have that, what am I doing? There we go. We actually got to go to 40 milliamps, because the resistors are high enough value there to limit current to protect things, but that's a 1000 ohm resistor, and then it goes through a diode to charge the capacitor. It also goes directly to ground when the output is low, so we're just getting straight current through there non-stop. But yeah, let's see how we do with the trim pipe. And that's weird. That one's glowing already when we are up here. So yeah, definitely we can go direct to ground, other than when I make a bump. So that's a low input, for sure. And it's holding the output low, no matter what. And we can go directly to the positive supply. And yeah, I don't know why The 555 is acting up like that. So, I got rid of the trim pot. I actually changed the supply voltage. That was the problem. Now we have them going back and forth, unless I hold the button. So I have a pull-up resistor. That's keeping the input high right there, 10,000 ohm resistor, but it sees 5 volts while the switch is open. When I close the switch, it connects to ground, as you can see there, to the reset pin, and it resets the 555 timer. We have a low output. So ultimately, we need a setup like this where it's either high, definitely high, or definitely low. Either the supply voltage, 5 volts, or the ground voltage of 0 volts. So we will raise this up to 12. And yeah, that other integrated circuit wasn't getting, you know, we're getting maxing out the current that I set right there of 40 milliamps. It'd be even worse if we had like 20, 50, 60. And yeah, wow, it's going, we shouldn't be getting those spikes. That's weird. Right there. Or definitely, yeah, we don't want 20. Now, what happens if you try to do 20 is it lowers the supply voltage right there. So, yeah, we exceeded this, and let's go back to 5. So that seems to be the problem, whereas the other integrated circuit seemed to work okay with that voltage. So yeah, for some reason, I thought this one would perform better, but it did worse when we put it up to 12 volts. So I noticed the red LED didn't look like it was turning on instantly. Looks like it does get better though when I attach the oscilloscope to the output. What I was looking for is a clean transition from ground to, you know, you don't get 5 volts at the output with these. But in case, let's speed this up and see what it looks like. Yeah, it looks like we are getting a smooth transition based on this right here. Hopefully that shows up pretty good. But when I come, instead of measuring at the output, measure where the LED and that resistor touch. I didn't, there we go. Wasn't expecting that to fight me so much there. There we go. Now, we will come back, and you can see that we got low. It kind of jumps around right there for whatever reason. So for some reason, attaching the oscilloscope probe to the output makes that go away, but that is not good. So I thought maybe I fried this 555 timer, so I grabbed another one again from the kit right there, NE555, and there we still have all that nonsense. It should be a smooth transition, just a straight up jump. And so again, pulling this out, not measuring at the LED on the other side of the resistor. Now going directly to the output right there. It's definitely a lot better, but you can see some wavering voltage sometimes. Looks like those might have been pretty smooth. Yeah, even when I look in person, it may not always shoot straight up. It may kind of go up, linger a little bit before going up, you know, very small amount. And sometimes it looks like it may be jumping around a little bit. So yeah, that's not good. I'm suspecting these probably weren't damaged. Something else going on. Okay, I figured it out. I grabbed a smoothing capacitor. I have a baggie full of capacitors. I was hoping to get a 1000 microfarad like that one, but it's 470 microfarad, pretty large. So it's just a supply rail right there. It's to help steady the supply voltages. And I put the jumper back to the resistor where we saw a whole bunch of weird bouncing going on before. And to get this to stop flashing like that, we gotta wait till it's going up. There we go, I'll just pause it. So there you can see, now we have should be a smooth transition right there. It is 0 volts until boom, suddenly it's 5 volts. That is what we want. So that's all I had to do was smooth out the power supply. So now I return the first 555 we used. I'm going to leave this one up here just as a reminder that we've used that one before. It's not a completely brand new component probably anymore. Power's off right now. Alright, so I'll turn it back on. We got 5 volts there. And it looks like I got the jumper at the LED again. And I think that was where we had it at before. But yeah, we'll kind of zoom in. And again, we got to wait till it's moving up. And yeah, it looks like we got a good jump right there. And I'm going to press this. And now we're going to go up to 12 volts. So this may jump off the screen. I'm sorry it's blurry. That's 60 milliamps. maximum that we can do. And yeah, now yeah, I can go to 12 volts. We are not maxing out the current. Looks like it's holding pretty steady. So what's happening is we're not sucking a bunch of charge out of the power supply all the time. You know, we have a capacitor here that is picking up the slack. And so yeah, hopefully that smoothed things out. Oh yeah, that's right. Looks like we're just measuring the voltage across the LED. And when it goes up, I'm going to pause it. And there you can see we have a smooth transition right there. So that's all we had to do to smooth things out, was to add a smoothing capacitor to the breadboard to help stabilize the power. So now we come back. I was hoping with this smoothing capacitor to the supply right there, we would get a different outcome. But again, this is the Radio Shack 555, the first one that I used. And if I lower it, it looks like it's, I already tested this out, looks like it's behaving pretty much the same. There we go. We got low enough where the output goes low. That's what we want. And when I kind of lose connection, it could give kind of any voltage. So seeing the flicker doesn't really mean anything. But there we go. I turned it up enough. Now the output's high. It's staying high. It should never do that. It should either be low and staying low if we go low enough, or if I get high enough, it should be alternating back and forth. Maybe it's behaving the way that it's supposed to, but it's not, you know, doing what you would expect, where if you have a high input, then an A stable will keep alternating, and a low input, then it will only be low. There's no logical reason why the output should be held high, unless there's something I'm not thinking of or whatever. But in case, gonna upload this video. It's kind of a bonus video. Hopefully you still enjoyed. Yeah, one reason why I don't make completely brand new circuits all the time is a lot of times it takes a long time to work the bugs out. And in this particular case, we can't use a changing voltage to either have this A-stable alternating or the output low. That's what I got from this. I have to, like with the push button, either give it a distinct high positive supply or low negative supply in order to get it to work properly. I can't give a slowly changing voltage that drifts above and below high and low, because it doesn't just pick up either high or low. It's got some weird middle ground region. So any case, hope you found that interesting. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.